Well, my dear participants, now I am going to talk about matrices and arrays. Matrix is the basis of many computing languages. Just matrix is the basis, like MATLAB software. MATLAB itself tells that most of the objects are there in the form of matrices and arrays. In SAS, statistical analysis system, they talk of PROC, and actually for defining, for programming, they use PROC IML. IML stands for Interactive Matrix Language. So, the main component of programming is matrix, and here also in R, matrix plays a very important role. So, matrices and arrays we are going to discuss. The function matrix is used to create a matrix, like M is equal to matrix C. Just I would like to run from here, say for example matrix, say it is C 1 comma 4 comma 5 comma 7 and n call or n rows, n call is equal to 2. So, a matrix has been created, a matrix of 2 by 2 has been created, but you see these elements are filled in the matrix column wise, not row wise. So, this is the main, it follows column order. If we want to enter row wise, we have to write by row is equal to true. Then see that now elements have been filled by 1 and then 4 in row, then 5 and then 7. So, this is you have to give the additional argument by row is equal to true to organize this elements of the matrix in row wise. Otherwise, by default it enters column wise. Now, here M is equal to matrix 1 is to 6 and n row is equal to 2, number of rows is equal to 2 and n call, number of column is equal to 3. So, these 6 elements 1, 2, 3 up to 6, they are organized in the form of a matrix which has 2 rows and 3 columns. So, we can print the matrix 1, 1, 2, 3, 4, 5, 6. So, this is the matrix. Now, we can dime stands for dimension of the matrix. There are 2 rows and 3 columns. So, dime function can be used to look into the dimension, dime. It is 2 by 3. Dime names. See, if you print M, here there is no names, neither row name nor column name. They are just having 1 comma 2 comma for rows and comma, after comma means we are selecting column. So, first column, second column and third column, but there is no name. So, we can use listed data object, and that is the function is dime names. So, dime names, and it is dime names M and listed letters. So, that means letters means first dimension, and that is row, letters 1 is to 2, and in the second dimension it is small letters 1 is to 3. So, after giving this, now we can print. So, here it has printed row names A, capital B, and column names small a, small b, small c. We can use another command, that is call names. Call names to change the column names. So call names X M is equal to and Samad, Radha, Umar. So now if you print this, you are having Samad is the first column, Radha is the second column, and Umar is the third column. But it has not changed rows. Then to change row names, see Muradabad, Aligarh. So now here Muradabad and Aligarh are the row names and column names are Samad, Radha and Umar. So naming does not affect anything, just it is row names and column names, because in graphics these names should appear and this plays a very important role, and we will discuss these things later. Now matrix operations in R. See, suppose we have a matrix. Here we are giving the argument and row is equal to 3, not column. So from the number of elements it decides itself that how many columns, how many rows should be there. Row is decided, but columns should be computed on the basis of number of elements. Since there are 9 elements, so that means there are n call is equal to 3. So we have computed this, we have defined this matrix, then B matrix we have defined, and this is the B matrix. Now addition of and subtraction of matrices. Just give A plus B, so it will give the A plus B individual elements will be added. See, for example, 4 plus 3, 7, 9 plus 9, 18, like that. And similarly, this negation operation, A minus B, it gives A minus B. Now we shall talk about component-wise matrix multiplication. Actually, the matrix at the position A11 should multiply with the matrix at position B11. Similarly, the element at A12 should multiply with B12, like that. So this is known as component-wise matrix multiplication. So this is the result. This is the result. And ordinary matrix multiplication. So here matrix multiplication operator is percent star percent. So here this is the ordinary matrix multiplication. So this is the matrix multiplication. We are multiplying matrix A with matrix B, and this is the result. To get the transpose of a matrix, we have to use T of matrix A, that is transpose. Transpose means we are converting rows into columns. So this is the rows have got to columns. So this is transpose of a matrix. Inverse of a matrix. The function solve is used to get inverse of a matrix. Now, if we multiply inverse of a matrix with the matrix, we should get identity matrix. So this is the identity matrix. This is the identity matrix, because A inverse A is equal to identity matrix. So this is the identity matrix we are getting, whose diagonals are 1s and non-diagonals are 0s. If Ax is equal to B, A is the matrix, X is a vector and B is the right hand side matrix vector. This implies that X is equal to A inverse B. So this is equivalent to X is equal to solve A comma B. Define vector B. Say for example, if we define vector B, then x is equal to solve a comma b. So, what it does? It first makes inverse of a and multiplies that with b, and this is the result. This is the result. This is the result. So, actually solve a comma b is nothing but a inverse b, a inverse b. Like you can get the same result, solve a and then percent and then b. We are getting the same result, 0.047, 1.26, like that. So, x is equal to solve a is nothing but a inverse b. The function C bind and R bind are very general function, and they can be used to get these are the binding. Say for example, x1 is a vector, x2 is also a vector. Say we are creating an object cx12 and that is on the basis of C bind. C bind stands for column wise binding of these vectors C. So, if you print cx12, it is column wise binding. This is the column of x1 and this is the column of x2. But if we want to bind them on row, it is like Rx12 is equal to R bind. So, see here the picture changes. Here it binds row wise, x1 row first, then x2 row second. And actually the kinds of object it has inside, R bind or C bind, they return the same object. If there are data frame I will talk later. So, here since vectors are being combined, the matrices are also the object created by them on the basis of C bind or R bind is also a matrix. Then suppose we want to get determinant of a matrix. So, determinant of a matrix, the function is det. Here det, determinant. Diagonalization, see here the same function diag has 3 output and it depends upon what argument we are giving to the function diag. Say for example, diag A, when argument is a matrix, it returns its diagonal elements. If argument is a vector, it returns diagonal matrix with the elements of in the argument as diagonal vector. But if diag argument is an integer, it returns identity matrix of that order. Say for example, we are having identity matrix of order 4. So, say for example, A is a matrix, and diag of A, it returns its diagonal elements 3, 5, 7. But if we have diag and here the argument is a vector, say 2, 4, 5, then in that situation it returns diagonal elements having the vector on the diagonal part. Similarly, suppose we have 6 elements, then in that situation it will be a matrix of order 4 by 4 and the diagonal elements are 2, 4, 5, 6. So, but if See, this is the diag C1, 2. But when argument is an integer, a positive integer, it returns an identity matrix of order of the integer. Like here, since 4 is the argument, it returns diagonal matrix of order 4 by 4. If we write diag, suppose you want to create a matrix of order, identity matrix of order 3, so you have to type diag 3 and it returns diagonal matrix, and you can assign this as capital I is equal to, and this is I. This is the I. So this is the role of diag. Diag, it decides what argument you are giving to the diag, and if you are giving an argument a matrix, it returns the diagonal elements, and if the diag is a vector, it returns diagonal matrix of having elements, and if diag is an integer, argument is an integer, it returns an identity matrix of that order. Now we shall talk about crossprod. Crossprod we know, crossprod A and comma B. So here it is nothing but it is crossprod, means it is A transpose B. So the function is crossprod. If we have, so here it is crossprod, that is A transpose B. It is A transpose B. T A percent star percent B. See, we are getting the same result. So instead of giving this operation, we can just write crossprod A comma B and it will make the transpose and multiply with the other element. But if we have only one argument A, so see what it will return, crossprod A. It is nothing but transpose of A and percent star percent and then A. So if we are having only one argument of crossprod, it makes transpose of A and the other element instead of B, it writes A, and we are getting the result crossprod. Suppose we are going to talk about eigenvalue decomposition. This is a very difficult problem in programming to getting eigenvectors and eigenvalues. C++ people make a lot of efforts to get these things. But here it is a very simple function eigen of A. And if you run this, it gives eigenvalues and eigenvectors. You can select only eigenvalues by V dollar values. Similarly, you can select eigenvectors, this thing. So this is the eigenvalue decomposition of a matrix. And actually, similarly, you can talk of SVD decomposition. So the function is SVD of A. So here you have got D diagonal elements, then U, and this is V. So similarly, you can get QR decomposition of a matrix if the function is QR. So this way we can get the result. we can talk about these things later. We can talk about these concepts, application of these concepts in the when we shall talk about regression modeling and other things. Now I shall talk about extraction operator. Here extraction operator, we are putting a comma inside these pair of brackets. Inside this pair of brackets we are putting a comma. So before comma it is extraction of rows, and after comma it is extraction of columns. Actually for functions we use parentheses, but for extraction we use these square brackets. And if there is no comma, actually for say for example, if we have created a vector like this, C 2 comma 4 comma 5 comma 3 we have here, and if we want to select first element and third element, then x, and we are using extraction operator, but here there is no comma because it is one dimensional, it is one dimensional array, and here 1 comma 3. So what it will do, it is selecting the first element and third element, that is 5, and if we want to deselect them and remaining report remaining, we can just make a negation. See here it has dropped first element and third element and reporting remaining, and that is 4 and 3. So this is the extraction operation in terms of vectors, but in terms of matrices, in matrices are two dimensional array, we can talk about a comma here in between. So before comma it is rows selection, and after comma it is column selection. Say if we are specifying both rows and column, so that means we are going into the first row and third column, so that will be a single element. So we have already created M matrix, control 2, M. So this is the matrix, and we want to select first the element in the first row and third column. So first row and third column it is 5. So M first row and comma and third column. So it is 5. It is 5. Similarly, if we are putting like this, here after comma means we are selecting columns. So we are selecting first column and second column, and if we run this command, here it is the first column which has been selected and second column. But suppose we want to select first column and then third column. So what we have to do, see, and here we will write first and third. So this is the first column has been selected and another object has been created. Even you can assign another object M1 to this, and you can do anything after that, like dit of M1 or any other operation. So this way you can extract. Here before comma means we are selecting rows, and if we don't have here anything in the column, it will be like this, M and then C 1 comma 3. So, we are selecting first row and third row, but we are not putting anything after the comma. So, that means all the columns are selected. See here, M subscript is out of bound. Oh, because we don't have 3 rows, so we have selected first and second row and all the columns are selected. See, so we have selected first and second row and all the columns have been selected. Similarly, if we want to select first and second row and the third column, then it is like this. It is like this. So, this way you can select the columns and then you can do operations. Then arrays. Array, the function array is used to create an array, like say for example A1 is equal to array, the function array is used, and here it is the element 2 comma 4 comma 5 comma 3 comma 2 comma 3. So, there are 6 elements and we have to give the argument dime is equal to, say we want to create 2 rows and 3 columns. So, dime is equal to this. Now, print A1, it has created a matrix of 2 rows and 3 columns, 2 rows and 3 columns. But if we change here the dimension, there are 6 elements, suppose we have 8 elements, 8 comma 9, and we want 2 rows, 2 columns and the third dimension is also 2. So, it will generate 3-dimensional array A1. So, it has generated, the first dimension is row, second dimension is column and third dimension is third subscript, that is 1 and 2. So, we can make use of these things and we can go for more than 2 dimension, like we can have dime C2 2 comma 2, but here your elements must be 2 into 2 into 2. So, they are 8 elements. If you write 2 here, that means 2 into 2 into 2 into 2, 2 to the 4, to the 8, to the 16. So, you have to enter here 16 elements, and say C 1 is to 8, 1 is to 8, comma. So, now 16 elements have been entered and we can define A1. It is like this. It is like this. So, we have generated 4-dimensional array by using the function array. So, this is the flexibility of dimension here. Now, we can get dimension dime of A1. What is the dimension? We know it is 2 by 2 by 2. So, we can have Similarly, we can have dime names to get the names. But I would like to come here in this screen. We are creating 2 by 2 by matrix. Then we are printing this A. Again, it is in the column order 1, 2, and then 3, 4, then 5, 6, then 7, 8. It is in the column order. Naming arrays, first thing dime. Dime is 2 by 2 by 2, and dime names to put the names, because here there is no names. 1, 2, 1, 2. Dime names. Here A1 list. The first dimension name is AB. Second dimension name is letters 3, 4. 3, 4 means it is CD. And third dimension name is D1, D2. So, once you have printed this, you will have this. The first dimension is AB, then second dimension is CD, and third dimension is D1, D2. So, this way you can create, and arrays can be used for creation of matrix also, like A2 is equal to array C1, 2, 3, and dime we have to put, it is 2, 2 comma 2. It is 2 comma 2. So, this way we can create these things. Now, I shall talk about extension in the next lecture. I shall talk about extension of these data objects, that is matrices and arrays and vectors. We are going to talk about data frame in the next lecture. So, that is a generalization of these things.